In part 4 of our lesson on graphs of tangent and cotangent, we're going to graph a cotangent function. So in this example, we're being asked to sketch one period of the graph of y equals 1/2 cotangent of 3/4 x minus pi over 3 plus 1. Let's go ahead and check your understanding on this one. So pause the video, work the example on your own, then restart the video to check your answer. So first, we're going to find the formula for all the vertical asymptotes, and we know that in order to do that, we're going to set the argument of the function equal to where the normal vertical asymptotes happen. So we know that for cotangent, the vertical asymptotes occur at n pi. So we take the argument of our function now, 3/4 x minus pi over 3, set it equal to n pi, and solve for x. So the first order of business will be to add pi over 3 to both sides. And we get 3/4 x is equal to pi over 3 plus n pi. Remember, my recommendation is to get a common denominator over here on the right-hand side first. So we know we're going to have to multiply n pi times 3 over 3. So we've got pi plus 3n pi divided by 3, and on the left-hand side we have 3/4 x. Now we need to multiply both sides by 4/3 to get the x by itself. And we're going to get that x is equal to, well, let's see if anything cancels. The 3 would have to go into both terms of the numerator, and it does not. So there's no canceling with the 3. The 3 here in the denominator and the 4 here in the numerator don't cancel. So we just have to multiply this out. It becomes 4 pi plus 12n pi over 9. So this is the formula which will find all of the vertical asymptotes of our function. And we know that to find the vertical asymptotes in our one cycle of cotangent, we need to plug in n is equal to 0 and n is equal to 1. So if we put a 0 in for n, that will wipe out this 12n pi term, and we have 4 pi over 9. If we put a 1 in for n, this becomes 4 pi plus 12 pi is 16 pi over 9. So that's where we expect our vertical asymptotes to be for our one cycle. Next, we're going to solve the inequality for the shifted cycle, and we know for cotangent we have to put the argument in an inequality in between 0 and pi, because that's where the one cycle of cotangent lives. So our inequality becomes 0 is less than 3/4 x minus pi over 3 is less than pi. So we're going to add pi over 3 to all three elements of the inequality. We get pi over 3 is less than 3/4 x is less than, now this would be 3 pi over 3. So 3 pi over 3 plus pi over 3 is 4 pi over 3. Now, to get the x by itself, we need to multiply by 4/3, so we have to do that to all three pieces. And we see our shifted cycle becomes 4 pi over 9 is less than x is less than 16 pi over 9. So this will be the starting x value of our cycle. This will be the ending x value of our cycle. And it agrees with where we said the vertical asymptotes would be. We know the first vertical asymptote begins the cotangent cycle, and the second vertical asymptote ends the cotangent cycle. So we're feeling pretty confident about moving forward. Now we want to find all these attributes of the graph, and in order to do that, we need to get the equation for the function into the standard form. So we know this is going to be 1/2 times the cotangent. We need to factor out the 3/4, which means we have to multiply everything on the inside by 4/3. So when we multiply this by 4/3, it becomes x. When we multiply this by 4/3, it becomes 4 pi over 9. And then we have plus 1. So now using this form, it's easy to find A, B, C, and D. The period for cotangent is found by doing pi over b, and in this case we know that b is equal to 3/4, so we have to do pi divided by 3/4, which turns into 4 pi over 3. So that's the time it takes to complete one cycle of the graph. The vertical stretch or compression is equal to the absolute value of A, and in this case, A is equal to 1/2. So this will be a vertical compression. All the y values are going to be half as big as they used to be. The phase shift is equal to letter C. Remember that C comes after the minus sign, so C is equal to 4 pi over 9. And because C is positive, that means this will be a horizontal shift to the right. Remember, phase shift is horizontal shift. The vertical shift comes from D, and in this case, D is positive 1, so that means the graph will shift upward by 1. The domain we get for free from the formula for the vertical asymptotes, because everywhere a vertical asymptote exists, the function cannot exist. So the domain is that x cannot equal 4 pi plus 12n pi over 9. Now the range for cotangent is -infinity to +infinity. So even though the y values are being affected, when you have an infinite function, it remains infinite. We are ready now to find the 5 key values. From solving the inequality for the shifted cycle, we know our starting x value is going to be 4 pi over 9, and our ending x value is going to be 16 pi over 9. find the midpoint, we have to add up the start and the end and divide by 2. So I'll take 1/2 times 4 pi over 9 plus 16 pi over 9. So that will be 1/2 of 20 pi over 9, which is going to equal 10 pi over 9. Now we see all of our denominators are 9, which is making our life easier at this point. So if we just look at the numerators and we think, what's halfway between 4 and 10? If we add up 4 and 10, we get 14. Half of 14 is 7. So the quarter point is going to be 7 pi over 9. And if you can't do that in your head, then you should write it out like we did here. But anytime you can make things go more quickly, please feel free to take advantage of that. Same thing here for the 3/4 point. Since my denominators are the same, I can just work with my numerators. 10 plus 16 is 26. Half of 26 is 13. So this will be 13 pi over 9. And now we have all of the x values of our 5 key points. We're ready now to look at our expected y values. We know from finding the formula for our vertical asymptotes and plugging in 0 and 1 for n, we found out that we're going to have vertical asymptotes at 4 pi over 9 and at 16 pi over 9. We know that cotangent normally goes 1, 0, -1. And our y values are going to be affected by letter A and letter D in our equation of the function. Letter A is equal to 1/2. And letter D is equal to 1. So we know that every y value is going to be multiplied by A and added by D. So every y value will get half as big and then shift up by 1. So our y values will be 1 times 1/2 is 1/2. 1/2 plus 1 is 1.5, or 3/2, whichever way you prefer to write it. 0 times 1/2 is 0 plus 1 is 1. -1 times 1/2 is -1/2. -1/2 plus 1 is +1/2. We have to check at least one value. Remember, it's the best to check all the values, but at least check one. And remember, don't use one of the root values because the graph could be flipped upside down and you wouldn't catch it. So let's say we're going to check this value of 3/2. So we'll need to plug 7 pi over 9 into the function for x, either here or here. Now in this case, since the denominator is 9, and I look over in this form of the equation, I see this denominator is 9. I think this might be the easier one to plug into this time, so I'm going to plug in to x right here. So we get 1/2 times the cotangent of 3/4. Now inside we've got 7 pi over 9 minus 4 pi over 9. Close the parenthesis, close the bracket, and add 1. We know that 7 pi over 9 minus 4 pi over 9 is going to be 3 pi over 9, which is pi over 3. So now we've got 1/2 cotangent. Let's figure out this argument here. we're going to have to take 3/4 times pi over 3, and then we'll have to add 1 here. This becomes 1/2 times the cotangent of pi over 4 plus 1, which is 1/2 times 1 plus 1, which is 3/2. So the value we were expecting to get turns out to be the value that we got. And we can feel confident moving forward now and plotting the points of our graph. Looking at our x values, they all have a denominator of 9, so we'll expect to go by pi over 9s on our graph. So we've got 1 pi over 9, 2, 3, 4 pi over 9 would be here. Then 5, 6, 7 pi over 9. 8, 9, 10 pi over 9. 11, 12, 13 pi over 9. 14, 15, 16 pi over 9. Now our y values, the smallest one we have is 1/2. The biggest one we have is 3/2. So maybe we want to go by halves here. So this would be 1/2. This would be 1. And this would be 3/2. We know that the first key value is a vertical asymptote at 4 pi over 9. And we know that the last key value is another vertical asymptote at 16 pi over 9. Now we're ready to plot the points. We've got 7 pi over 9, 3/2. 10 pi over 9, 1. And 13 pi over 9, 1/2. Remember, my suggestion is to start from this middle point and make a smooth curve approaching the asymptote, then start again from that middle point and make a smooth curve approaching the other asymptote. Now let's check all the attributes of the graph. First, we'll look at the period. The ending value is 16 pi over 9. The starting value is 4 pi over 9. 16 minus 4 is 12. 12 pi over 9 reduces to 4 pi over 3, so the period checked out. We can see that the vertical compression was by a factor of 1/2, because normally the y values are a distance apart of 1, but we can see from this y value to this y value it's only going up by 1/2, and from this center of y value to the next one it's only going down by 1/2. So that is a vertical compression by a factor of 1/2. Let's look at the phase shift now. We know that for the unaltered graph of cotangent, the y-axis is where the first vertical asymptote happens, and we can see that that has been shifted to the right by 4 pi over 9. So our phase shift checks out. And lastly, let's check this vertical shift. We know that this middle key point here of the 5 key points, we know that middle point is normally down here on the x-axis, and we can see that it has been shifted up by 1. so the vertical shift checks out as well. So here is our graph of this cotangent function.